Imagine you walk into a massive, heavily funded laboratory. Inside, there are, 25 of the most advanced billion-dollar artificial brains on the planet.
Built by fiercely competitive tech companies, right?
Exactly. And you stand in the center of the room and you ask them a really profound, deeply human, open-ended question like, what is time? You would naturally expect 25 mind-blowing, vastly different answers reflecting their different architectures, but instead they all open their mouths and recite the exact same poem.
It is a genuinely unsettling scenario, but mathematically speaking, it's no longer hypothetical.
Wow.
Yeah, we are watching a real-time homogenization of machine intelligence.
And that is the mission for today's deep dive. We are unpacking a massive, highly revealing study from researchers at Washington, Carnegie Mellon, and Stanford universities.
Really groundbreaking piece of work.
It is. We're exploring a phenomenon where independent generative models aren't just giving similar answers, they are fundamentally collapsing into what scientists are now officially classifying as an artificial hive mind.
Right, and the implications here, they completely upend how we understand the trajectory of generative systems.
Which is exactly why this matters so much for you, the listener. Because, if you use these tools for brainstorming, or to prep for a high-stakes meeting, or to find a fresh angle on a stubborn problem, you probably assume that bouncing between different models gives you a diverse set of perspectives.
You think you're getting a second opinion by opening a new tab.
Right. But this research strongly suggests that the second opinion is, well, it's just the first opinion wearing a slightly different mathematical disguise.
You're tapping into a centralized statistical consensus, not some, diverse brain trust.
It's like walking into a massive futuristic ice cream shop that heavily advertises 25 distinct, mind-blowing, cutting-edge flavors. You've got all the big brands represented.
I love this analogy.
But when you actually sit down and taste them, every single one of those 25 flavors just tastes like vanilla.
Just straight vanilla.
Yeah. And to figure out why the global supply chain of artificial intelligence only produces vanilla, we have to look at how the scientists conducted their taste test.
Right. The methodology is what separates this from mere anecdotal observation. The researchers from Washington, Carnegie Mellon, and Stanford didn't just casually poke at a few consumer-facing chat windows.
Right, it was much bigger than that.
Exactly. They analyzed the underlying behavior of 25 different prominent language models, which gives us a highly robust cross-section of the entire industry's current architecture.
They built an entirely new evaluation framework to test them, too. A massive data set they called Infinity Chat.
Infinity Chat.
And it consisted of roughly 26,000 real-world user queries. The crucial detail here is that these weren't coding prompts or trivia questions. They were queries specifically focused on creativity and ideation.
That's the key difference.
Yeah, they organized the data into 6 broad categories, drilled down into 17 subcategories, and just threw it at the models to see what would happen.
And that curation fundamentally changes the nature of the test. They needed a framework that evaluated the variance of thought, rather than just the accuracy of retrieval.
Okay, wait, I have to push back on this premise just a little bit. Because, aren't these systems supposed to converge on the same answer?
How do you mean?
Well, if I ask an AI what 2 plus 2 is or what year the Magna Carta was signed, I absolutely want all 25 models to spit out the exact same number. If one model decides to be creative and tells me 2 plus 2 equals an eggplant, the system is broken.
Right. Nobody wants an eggplant for an answer.
Exactly. So shouldn't we view this consensus as a massive technical achievement?
Well, for factual retrieval, absolutely. But that touches on the fundamental mechanism of how these models generate text. Large language models don't store facts in a database like a filing cabinet. They calculate the probability of the next word in a sequence based on their training. So when you ask for the Magna Carta's date, the probability distribution is incredibly sharp. There's only one statistically viable peak, which is 1215. The rest of the landscape is essentially flat.
Because the entire internet agrees on 1215?
Precisely. But the Infinity Chat queries were completely different. They were deliberately designed to be probabilistic playgrounds.
Oh, I like that term. Probabilistic playgrounds.
Yeah, these were open-ended prompts. Philosophical inquiries, creative writing tasks, metaphorical requests. In those scenarios, the mathematical landscape of possible next words should be sprawling and mountainous.
It shouldn't just be one peak.
Exactly. There should be thousands of different, equally valid statistical peaks for the model to climb.
Okay, that makes sense. If the mathematical landscape is wide open, the answers should scatter in wildly different directions. Like, if you ask 25 different human writers to write a poem about the ocean, the variance is going to be massive.
It would be huge, yeah.
But the researchers found the complete opposite with the machines. Which brings us to the specific query that completely blew the lid off this behavior.
The divergence between what we expected from the mathematical landscape and what the models actually produced is stunning.
So out of those 26,000 queries, they asked the models, what is time? Which is a gorgeous open-ended prompt.
It really is.
You could talk about entropy, the decay of cells, a ticking clock, or just a subjective feeling. The possibilities are truly endless. Yet these 25 independent models spat out almost identical metaphors.
They clustered around highly specific poetic imagery.
Right. Some models went with the classic, time is like a river, which, sure, it's a bit cliche, but fine. But then multiple models generated an intensely specific phrase. They said, quote, it is like a weaver of moments.
A weaver of moments.
Yeah. Here's where it gets really interesting. If these are 25 different models, presumably built by different teams, why are they all writing the exact same poetry?
Well, statistically speaking, for independent generative models with different parameter counts and distinct fine-tuning protocols to independently arrive at the exact phrasing weaver of moments, it points to a massive underlying structural convergence.
And the researchers didn't just look at the phrasing, right? They quantified it.
They did.
They measured the semantic overlap between these 25 different models, and the similarity scores ranged between 71 and 82%, up to 82% semantic similarity for open-ended creative prompts.
It's staggering.
In some cases, whole text fragments were virtually identical word for word.
What's fascinating here is that the individual architecture of the model, whether it has 7 billion parameters or 70 billion parameters, is becoming totally irrelevant. They are exhibiting the core characteristics of an artificial hive mind.
An artificial hive mind. So how are we defining that exactly?
Well, in biological systems, a hive mind occurs when individual organisms suppress their unique behavioral patterns to operate in a coordinated, unified manner.
Like bees prioritizing the hive over themselves.
Yes, exactly. But in the latent space of artificial intelligence, we are seeing separate algorithms diluting their individual probability distributions. They are moving away from the edges of their training and collapsing toward a single unified center of gravity.
But surely the scientists tried to break them out of this, right? There has to be a dial you can turn to force the machine to be weird.
They did try exactly that. They manipulated the temperature parameter.
A temperature.
Right. In machine learning, turning up the temperature mathematically flattens the probability distribution. It forces the model to ignore the most obvious, highly ranked next word and randomly select a less probable word.
So it's literally a mathematical command to be more diverse and creative.
Exactly.
But it still failed, because even when ordered to be random, the models still repeated the same underlying thematic patterns. They just used slightly weirder vocabulary to say the exact same thing.
Because if the underlying map of the concept has already shrunk, turning up the randomness just makes the system bounce around inside a very tiny box. The researchers officially diagnosed this persistent, unavoidable homogenization as intermodal collapse.
Intermodal collapse. Okay, let's unpack this. What is actually causing the box to shrink so dramatically? Because the study points to 3 specific technical causes driving this phenomenon. Let's look at the first one, shared training data sets.
Right. To build a foundational model, you need to map the statistical relationships between hundreds of billions of words. And to get that much text, you have to scrape the internet.
You just vacuum up everything.
You do. And the reality of the industry is that almost every major player is dipping their cup into the exact same well.
Right. They're all ingesting Wikipedia, the same massive repositories of public domain books, the same news archives, the same Reddit forums.
They share a baseline dimensional map of human language. If 25 different people all learn English by reading the exact same 10 novels, their vocabulary and their metaphors are naturally going to align.
That part feels intuitive. I mean, they share the same diet, so they produce the same output. But models update constantly, right?
They do.
They are crawling the live web right now, ingesting new articles, new blogs, new human interactions. Shouldn't that constant influx of new data keep them diverse? Why is the collapse actually accelerating?
That brings us to the second and arguably most destructive cause, synthetic data. And we aren't just talking about a few AI-generated articles slipping into the mix. We are talking about model autophagy disorder, or MA.
MAD. The acronym alone sounds ominous.
It perfectly describes the mechanics of what's happening, though. Autophagy means self-eating. In the early days, these models were trained exclusively on human output.
Because that's all there was.
Right. And humans write with a massive long tail of eccentricity. We use weird slang, we invent bizarre metaphors, we structure our sentences in highly idiosyncratic ways.
We are wonderfully inconsistent.
Exactly. But an AI doesn't output that long tail. Because an AI always calculates the most probable next word, it inherently chops off the eccentric edges of language.
Oh, I see.
If humans use a strange word 1% of the time, the AI will predict it 0% of the time, because it's never the mathematically optimal choice. It only produces the smooth, highly probable center.
So when the AI writes an article, it's using a much narrower, safer vocabulary than a human would.
Now imagine the internet flooding with billions of words of that narrow, safe, AI-generated text. When the next generation of models scrapes the internet for fresh training data, they aren't ingesting human eccentricity anymore.
Oh, wow. They are ingesting the chopped-off, homogenized output of the previous models.
Exactly.
So it's a massive mathematical feedback loop. The first model refuses to use the weird 1% of words, so it floods the internet with the 99% normal words.
Yes.
Then the next model trains on that internet and calculates that the normal words are now even more mathematically probable, so it chops off another 5% of the edges.
That is precisely what is known as dimensional collapse. With every generation, the probability distribution of language literally shrinks. The vocabulary gets tighter, the syntax gets more predictable, and the concepts merge.
It's eating its own statistical exhaust.
The models are eating their own statistical exhaust, and it is starving them of diversity.
But wait, human engineers are still steering these ships, right? I mean, before a company releases an AI to the public, they spend months fine-tuning it. Why aren't the engineers noticing this collapse and manually correcting it?
That leads us to the third cause, which is honestly the most ironic part of this entire phenomenon. The human engineers aren't fixing the collapse. Their fine-tuning process is actually the final nail in the coffin.
Wait, really? How?
It comes down to the reward system, specifically RLHF, reinforcement learning from human feedback.
How does that work under the hood?
Before a model is deployed, human raters sit at computers and are shown two different answers generated by the AI for a single prompt. The human's job is to choose the better answer. The algorithm then mathematically updates its neural network to favor the traits of the winning answer.
Okay, so if the human chooses the creative answer, the AI learns to be more creative.
In theory. But these human raters are given strict corporate guidelines. They are instructed to prioritize answers that are universally helpful, clear, and unpolarized.
I see where this is going.
They are explicitly told to avoid anything that could be construed as weird, disjointed, or confusing to a general user.
So it's essentially a giant echo chamber. Okay, let's unpack this with an analogy. It's like a massive GPS traffic jam.
A traffic jam.
Yeah, like a navigation app. If the system is constantly rewarded for finding the single most optimized, friction-free route, eventually it sends every single driver down the exact same highway.
Right.
It creates a massive traffic jam of consensus, while the weird, scenic back roads, the truly creative, unconventional routes are completely abandoned because they aren't mathematically optimized for the average driver.
That is exactly what happens. We connect this to the bigger picture. You can see how devastating RLHF is to divergent thinking. True creativity requires taking a scenic back road.
It requires friction.
Absolutely. A brilliant poem or a disruptive business idea is rarely universally agreeable at first glance. It usually challenges the consensus. But the human raters are mathematically penalizing the AI every time it takes a back road.
The system is literally being computationally rewarded for moving to the dead center of the bell curve.
We are systematically training the eccentricity out of the machine. The algorithm learns that the center of the bell curve is the only mathematically viable place to exist.
Wow.
When you combine shared baseline datasets, the dimensional collapse of model autophagy disorder, and a fine-tuning process that punishes divergence, the artificial hive mind isn't a glitch. It is the guaranteed destination.
So what does this all mean? Let's bring this right back to you, the listener, sitting at your desk. You've got a complex problem, maybe you're stuck on a creative project, and you think, we'll run this past a few different AI tools to see if I can get a fresh spark.
A lot of people do that.
Right. But what this study from Washington, Carnegie Mellon, and Stanford is definitively proving is that you need to fundamentally rethink what that tool actually is.
You have to shed the illusion that you are consulting a diverse panel of experts.
Exactly. We tend to anthropomorphize these systems. We think of them as artificial brains that can ponder a question from unique angles. But they aren't brains. They are cultural mirrors, and right now they are trapped in a hall of mirrors. When you ask an AI to be creative, you aren't asking a machine to invent something novel. You are literally asking an algorithm to calculate the statistical average of human thought.
And the statistical average of human thought is, by definition, the exact opposite of creativity.
Right.
AI is an unparalleled technology for summarizing the consensus, for structuring the known, and for finding the middle ground. It is incredibly powerful when you need the middle of the bell curve.
But you cannot rely on a consensus machine to break the mold. It is mathematically designed to be average, which leaves us with a pretty profound question to end on.
Yeah, it does.
We started this deep dive talking about the utopian promise of AI, this idea that machines would unlock a new frontier of diverse, out-of-the-box thinking.
That was the dream.
But if all of our most advanced artificial brains are inevitably collapsing into a single, predictable, homogenized hive mind, where does that leave us? Who will we turn to when we need a truly original, disruptive idea?
It's a sobering thought.
Our human flaws, our stubborn disagreements, our messy friction, and our sheer inability to ever share a single hive mind actually the only true sources of innovation we have left. It's something to mull over the next time you ask an algorithm for a second opinion, only to realize it's just repeating the first.